So in this video, I will be discussing about packed and unpacked array in details with the help of few examples. So let's begin. So first I will declare an unpacked array and let's name it ar underscore u. So how could you recognize whether it's a packed array or an unpacked array? In unpacked array, the dimensions are declared to the right hand side of the variable like this. So let's give this unpacked array 5 elements and each element will be of type int. So basically this is an unpacked array of 5 ints, and unpacked array can be of any data type. So I could have used logic, so this would have been 5 elements of logic data type, and I could have used byte, long int, etc. So this is how you declare an unpacked array. So how do we declare a packed array? So to do that, we just have to declare all the dimensions on the left hand side of the variable like this. So just a second. Underscore p. So this is an example of packed array, and unlike unpacked array, packed array can only be of data types like logic, bit, and wire. Those are of only 1 bit. Each elements are stored in separate memory location, and in most of the SystemVerilog environment, those locations are word aligned or 32 bits aligned. So for operations which requires 32-bit elements or multiple of 32-bit elements, packed array, I mean unpacked array might be more efficient because as I've already said that most of the Verilog environments are 32-bit aligned. But as a matter of fact, unpacked array are more efficient because in this each elements are not stored in separate memory location. Instead, each elements are set of contiguous bits. So it's like a vector of 5 elements. So you can just go ahead and do direct assignment to unpacked array and it won't show any error. So let me demonstrate it. So what I'm about to do is so I will assign a value of 5-bit and inside the initial block I will use $monitor. I will rather use $string for now. Because we have to print the value immediately. And I will print the value of the packed array. So let's run the code. Let's check for any compilation error. Okay, what I did. Oh, I got it. I'm using the dollar $stop in the wrong way because to print the values of an array, should have used percentage %p. Now let's run the code for one more time. Okay, it's fine. Now let's go ahead and simulate the code. So as you can see right there on the console that we are getting 11, which is the correct value, and it's the decimal equivalent of this binary value right here. So that's the thing with unpacked array, that we cannot assign anything directly to it. So let's try to assign the same value or a different value. Maybe since it's a long int, so let's assign 53 and let's see what will happen. First, I will check for any compilation error. See, we are prompted with the error. So it clearly mentions right here on the second line that we cannot assign a packed type bit signal to an unpacked type signal. So by default, all of these values are of packed type because they are sets of contiguous bits. So you cannot assign them to an unpacked array. So the question arises that how should we assign any value to an unpacked type? So I will show you. So here, if you want to assign value to an unpacked type, you have to assign or mention the value for each element. So one of the easiest ways is just like this. And since there are 5 elements, you could mention 5 elements. So these are 5 elements, and let's check again for any compilation error. Okay, now the values are assigned. So here you can see that for unpacked array that the values are not set of contiguous bits. Instead, each elements are stored in separate memory location. So to print the value of unpacked array, I will do the same thing. I will use the $stop. This time I will print the value of unpacked array. So let's simulate the code. Remember, %p comes in pretty handy when you have to print the value of array elements, even struct or unions. For them also, %p is very useful. Okay, here you can see that all the elements are being printed correctly. So this is how you declare or initialize values to an unpacked array, and this is how you declare or initialize values to packed array. So other than this, packed array supports all kind of arithmetic operation directly assigned to it. So we could have done, let's say, in the next time slot, I'm assigning directly the addition between two numbers, let's say 32 plus 8. So we will print the value for one more time. First, let's check for any possible compilation errors. Okay, there are no errors. Now let's simulate the code. Okay, so I have made a mistake. So since the packed array is of 5 bits, it cannot support addition of two ints. One is 32, the other one is 8. So that's why the result is getting truncated and we are only getting 8. So to correct that, I will give it a value of, let's say, 62 bits, and then I will run the code again. Now we should get the correct value. See, right here we are getting 40, which is the addition of 32 and 8. So this was a small example and demonstration of how to use a single dimension packed and unpacked array. So let's move on with two dimension packed and unpacked array. So first I will write an example of two dimension unpacked array. So let's name the module test again, and I will name that packed array to be AI, and I will declare the dimensions on the right hand side since it is an unpacked array. Let's the first element to be of 3 and the second to be of 4. So that's how we declare our two dimension unpacked array. And if we want to assign a value or any value to any two dimension unpacked array, we have to do the same thing. So instead of int, we can just also use logic, and each element is of, let's say, 4 bits. So we can assign values like that. So the dimension is 3 times 4. So as per the first dimension, there are 3 elements. So I will just create a rough sketch or structure, and inside each 3 elements there are 4 elements. So to make it more readable, I will move it to the next line. Okay. So inside this one there will be 4 elements. So I will just copy and paste it. So similarly, inside this, okay, 4. Okay, I did make some mistake. Similarly here. The editor of QuestaSim can be quite annoying. Just remember this. Okay, so there are 4 elements here also. I think it is correct. So, okay, that's correct. Now I will give some values to each element, and remember, each element is of 4-bit logic data type. And if you want to like sum up the entire variable, you can see that it's a 2-dimensional unpacked array of packed arrays. It is because like when you want to refer, like when you want to, I mean, print any element, you will refer from the right side dimension first. So first of all, there are 3 elements, and each 3 elements have 4 unpacked elements, and each 4 unpacked elements have a 4-bit packed element. So that's how sums up in totality. So first, I will assign some value here. So that's how you assign values to a two-dimensional unpacked array. And let's go ahead and check for any compilation error. Okay, there are no errors. And we can go ahead and print the values. Let's simulate the code. As you can see right here that we are getting all the values of each element in decimal, but these are the correct values. You can also print the values in binary if you want to using a for loop. So I will show that. I will use for each and I will iterate through every element. So to do that, we'll just write AI, and since it's a two-dimensional unpacked array and I want to iterate through each of the elements, I will do something like this. And for each element, I will display the value using $display. Okay, so let's go ahead and check for any compilation errors. Okay, there are no errors. So let's simulate the code. So as you can see right here, this is how you can simulate or you can print the value of each element separately, and I have done that in binary, and you can mix and match that. Every value is correct as mentioned right here. So this is how things become complicated with unpacked arrays, but the plus side is that the elements can be of any data type. I have used logic here, could have used byte, I could have used long int, short int, integer, etc. You could also mention a default value which will be assigned to every element, and to do that we have to use the default keyword. So just write default, and since it turned red, it is determined by the compiler that it's a SystemVerilog keyword. Oh, great. And just give any value. So since each four elements are of 4 bits, so I will give a 4-bit value. So even if you give a 5-bit value, it will be truncated. So it doesn't matter. But let's run the code to check whether all the values or all the elements are aligned with this value or not. First, I will check for any compilation error. Okay, the code is just fine. Then I will simulate the code. So as you can see right here, that each of the elements are assigned with the default value of 101, and the code is working just fine. And also 101 translates to 5 in decimal, so that's why you are seeing decimal here. And the reason that the strobe is getting printed after the for loop or like the display element is because display operates in active region and stop operates in the postponed region, which comes later after the active region. So basically that's how you declare or initialize some values to an unpacked array, and that's how you also print out all the elements in an unpacked array. And the most convenient one is %p, but if you want to print each element separately, then you can use a for loop or for each. So unlike this, initializing or declaring some values for packed array is pretty simple and straightforward. Could just declare a packed array, let's say of logic type of 31-bit, and let's name it pi, and let's make it 2-dimension. So let's to be of 2 bits, 3 bits, and this to be of 4 bits. So for this packed array, there are three elements and each three elements are of 4 bits each. So since packed array works like contiguous bits of vectors, so you can directly assign any value. So, so what's 3 times 4? It's 12. So we can directly assign a value of 12 bit. And it will work just fine. So we can go ahead and print using the %p, and let's simulate the code. So as you can see right here that we are getting all the values correctly, and %p is printing each element, and there are three elements and each element are of 4 bits. And here we can see that the first element was 0101, which is 5 in decimal, and similarly 11 is 3, and 1100 is, or I should say 1100 in binary is 12 in decimal. And like the unpacked array, you can also print values of each element separately. So I will do it. So here I will change it to bi, and using that I will be printing value of each element separately in binary format. I will save the code and I will run it for one more time. So as you can see right here, each values are getting printed separately. And okay, so this looks kind of untidy. What if I want to print the values of the second dimension? So I should have done like that. Pi, and okay, let's run the code for one more time. So this time I will be printing the values of three elements, and each three elements will be printed separately, and each three elements are of 4 bits, which is mentioned here in the second dimension. So as you can see right here that each element is getting printed with respect to the first dimension correctly, as you can check and compare right here. So that is the added benefit with packed array, that you can do bit level manipulation with ease, but the downside is that you can only use the bit level data types such as logic, bit, wire, reg, etc. And unlike this, you can use any data types for unpacked array. So in this video, my aim was to demonstrate the sheer basics, that how do we declare any unpacked or packed arrays, and how do we initialize or pass any values to its element, and how do we print the value of each element. So for our next video, I will be showing you ways and methods that how is it possible to assign an unpacked array to packed arrays and packed arrays to unpacked arrays. So stay tuned for more, and thank you so much for watching this video.